Honorable President and guests, the Infosys Prize in Physical Sciences for the year 2015 is awarded to Professor G. Ravindra Kumar for his pioneering experimental contribution to the physics of high-intensity laser matter interactions, in particular for providing, for the first time, unequivocal evidence of turbulent magnetic fields and the discovery of terahertz frequency acoustic waves in laser-produced hot, dense plasma. These results have significance to testing stellar and astrophysical scenarios. Now let me explain a bit more of what this really is all about. The most common form of matter is not solid, it's not liquid, it's not neutral gas. It's nothing you experienced before, and hopefully you will not, but the most common form is plasma. Hot plasma pervades the entire universe, filling all conceivable place. Stars are simply plasma spheres. Stars shine by having nuclear fusion in their cores. In other words, fusion is merely a chemical reaction in hot plasma. So I hope you appreciate the importance of plasma by now. Dr. Ravindra Kumar's work employs ultra-short, femtosecond, intense bursts of laser interacting with matter to produce high-temperature plasma. He and his group at TIFR Mumbai use a variety of rather, I must say, clever diagnostic tools to probe and study the plasma that they create in the lab. Their work is applicable and highly relevant to understanding plasma physics, to astrophysics, engineering issues in fusion reactors, and to the development of tools that would actually be useful on Earth. So I thought I'd give a few examples of what his work touches on. Let me start off with plasma physics proper. The intense laser pulse, upon interacting with a piece of metal, let's say, results in emission of electrons, i.e., a very intense current, the result of which is a very strong magnetic field, mega-Gauss or more. That is about 100 million times stronger than the field we experience here on Earth. This is naturally a very good starting point for the study of the physics of plasma, in particular, turbulence in plasma. Now, you might think, oh, this is getting too detailed. Not only we're talking hot stuff, how does small variations in plasma matter? Well, they matter tremendously. The solar wind that comes off from the sun, if it were not for the turbulence, would have made our life unbearable. It's the turbulence which, in fact, mediates very strong shocks and prevent these energetic particles from reaching Earth, and which is why we actually can live without being affected by the solar wind. So thanks to turbulence in plasma, you need to understand that. Nuclear fusion, we all know why that's something we probably highly desire, but there are many technical challenges in nuclear fusion. Minimizing reflected energy is a major goal in this area, and his group has demonstrated almost complete absorption using sub-wavelength structures. Again, a rather clever idea. Finally, let me come to astrophysics, my own subject. The least well-understood phenomena in modern astrophysics is the turbulence and generation and amplification of magnetic fields. The universe begins very hot, big plasma, but no magnetic fields. But very quickly, magnetic fields develop. And just as I told you how magnetic fields are important for our own life here on Earth, magnetic fields determine the history or the evolutionary consequence of all sorts of processes in astrophysics. And this is very curious because magnetism is a very minor force energetically, and yet it has major impact. Dr. Ravindra Kumar's discovery of terahertz acoustic waves, in fact, may well explain or account for a long-standing problem in astrophysics, how a stellar core collapses to a neutron star, and it might be something to do with these terahertz acoustic waves. Turbulence in interstellar plasma is extremely important because without this turbulence, the development of very strong shocks which are another way of saying blast waves, or is a major part of astrophysics, is also related to actually understanding turbulence and magnetic field generation. Okay, so I've given you the big picture, but I know that some of you may well wonder at this point, that's all well and good, but what's Ravindra Kumar's work going to do for me today, now? Okay, we could start off and say that it has the potential to build build very high energy particle accelerators. Okay, I know that's not of much interest. Okay, how about maybe helping nuclear fusion reactions? Okay, it's getting interesting. But how about tabletop hard X-ray sources and mega electron volt protons that could cure your cancer without all the chemotherapy by exactly directing for absorption at the layer where the cancer is happening? I'm sure you'd agree that's very, very useful. But independent of that, I'm very happy that Dr. Ravindra Kumar's work has brought astrophysics to the laboratory.
Thank you. And here is Professor Kumar and his quest for scientific inquiry. Can we have the video, please?
All of us as children are always asking questions. It is just that some of us stop asking questions after some time. But if you get into a science or engineering or some profession which asks you these questions, you discover that the unknowns are more than the knowns. And you're upset with yourself that you don't know so much. That's a huge driver. It can be very addictive that I want to know the next answer, I want to know the answer to that after that. And in my case, an experiment that works is not interesting anymore. What doesn't work makes me come back into the lab. You put me in any other context, I think I would run away and come back into the lab, because this is where we truly belong.
Ladies and gentlemen, please welcome on stage Professor G. Ravindra Kumar. I request Mr. Chris Gopalakrishnan to join us on stage, and I request the Honorable President to present the Infosys Prize in Physical Sciences to Professor G. Ravindra Kumar.
What a moment, something that I'll cherish for the rest of my life. Well, Honorable President, distinguished members of the Infosys Foundation, jury chairs, members, and invitees. With this one recognition, a highly coveted one, you have provided great inspiration to me, my innumerable students, colleagues, co-workers, collaborators. And not just inspiration, you've also challenged us. You have actually posed a very big challenge to us to define and pursue much tougher goals. We've been privileged to be a part of the scientifically rich, nurturing world that the Tata Institute of Fundamental Research provides. And we are particularly grateful that you have recognized experimental physics. It's very pleasing that this ceremony comes just 2 days after a path-breaking advance in experimental science that Professor Kulkarni will tell you much more about, the discovery of the gravitational waves. It's been a long cherished dream, first proposed by Einstein in 1915, and the results were announced just 2 days ago. So this is a monumental event in our lives, and it is also a great recognition of the value of experimental science. Our country, which is now very aspirational with lots of young people, is trying to become a very advanced nation. And without solid, top-class experimental science, we're not going to reach there. So it's my dream that the Indian government and the Indian society at large encourages children to take up science, enjoy their work, and make new path-breaking discoveries. On a personal note, I thank all my teachers, innumerable mentors, students, co-workers. Some of my mentors are sitting here. I bow to them for what they have done for me. And actually, this is a recognition of all the things that they have contributed over the years. Of course, my family, my wife Madhvi, Ashraya, Asmita, my children are here. They have tolerated my vagaries of running to the lab for a long time. And my parents, who have made innumerable sacrifices, and my sisters and the extended family. They have all given me the feet to walk with and the wings to fly on. It's truly a great moment in my life. I am humbled. Thank you very much.